Hey team! Today we are going to be talking about energy, but I want to start with a quick review of force. So, if you recall, we said the definition of force was a push or a pull. And this is pretty intuitive. We think of, okay, when we put forces, when we apply a force to something or a force is applied to us, we feel that physically as some sort of push or some sort of pull against us. Now, we're going to be talking about energy today, but the definition of energy is just as intuitive as the definition of force. So, in your last screencast, I talked about work, and I said work measured change in energy. And so, our definition of energy is going to incorporate work. Energy here. Energy is the ability to do work. I'm going to write that down. Ability. The ability to do work, or the ability to apply a force over a distance. So now this is essentially saying the same thing because, as you probably recall, work is equal to force times distance. So work, energy being the ability to do work or the ability to apply a force over a distance, is essentially the same thing because work equals force times distance. But there are a couple different types of energy that we're going to talk about here today. So zoom out for a second. So this is our grand definition, energy, the ability to do work. But we've got a couple different types of energy. And the first type of energy is the energy of motion, or kinetic energy. Zoom in over here. So kinetic energies are energy of motion. And I want you to imagine a scenario for a second. Let's imagine that we have a bowling ball rolling across the floor at, let's say, 1 meter per second. And at the other end, we have a wall, and in that wall, we have a nail sticking out right here. Now, I want you to imagine if the bowling ball rolls over to and hits this nail, boink. I know I just had it levitating there. But imagine the bowling ball hits the nail. It's going to drive the nail into the wall. It's going to apply a force over a distance. So this bowling ball that's in motion, it has energy, and the energy is contained within its motion. So this thing has the ability to do work. It has energy. Okay, and let's give this bowling ball a mass. Let's say that it is 1 kilogram. And we actually have an equation for kinetic energy. We can say kinetic energy, this energy of motion, is equal to 1/2 mv squared. Okay? So for this example here, the kinetic energy of our ball is equal to 1/2 times our mass of ball, which is 1 kilogram, times the velocity squared, which is 1 meter per second, that whole thing squared. So we end up here with something that looks like this. We have basically 1/2 a kilogram, a meter times a meter divided by a second times a second, if we did that whole thing out. That's how much kinetic energy we have here. But I want you to look at this a little bit more closely. Right here, we've got a kilogram meter per second squared. Well, what is this term? You guys know this. This is a Newton. And then we're left over here with a meter, which is still a meter. But so all told, this whole term is equal to a Newton meter. A Newton meter. which, as you guys remember from your definition of work, we said work is equal to force times distance, which was equal to a Newton meter. And we said that whole thing was equal, we called that Newton meter a joule. So here you have it. Kinetic energy is measured in joules. So, the ability of an object to do work. Okay, now we're going to talk about a second type of energy, and this is potential energy. Potential energy. Now, there are many different types of potential energy. There's chemical potential energy. This is the type of potential energy that has to do with bonds between molecules. So, for example, all the food that you eat, the energy within that food, the energy that powers your body, your cells, is provided to you by breaking the bonds between your food. So chemical potential energy exists in bonds. So here's another type of potential energy. This is elastic potential energy, the energy contained within the slingshot. But I spelled elastic wrong there, fixed it. The type of energy the type of potential energy that we are going to focus on in this class is gravitational potential energy. So all these types of potential energy, the thing that they all have in common is this is the energy of position. Now, these things aren't moving, but they contain energy in the fact that if their position puts them in a place of energy. So going back to our bowling ball example, let's select this here and stick it right down here. And now we're going to flip it on its side. And instead of giving this bowling ball, okay, so we've got our 1 kilogram bowling ball again, and let's say we're holding it for right now. So imagine there's an invisible hand holding this bowling ball up. So it's not yet in motion, but let's say that it is 1 meter above the nail. So much like kinetic energy, we had an equation to describe the energy. We've got an equation to describe the energy of position here. So this is our gravitational potential energy equation is equal to the mass times the acceleration due to gravity. Right? That looked more like a Q than a G. So our acceleration due to gravity and the height of our bowling ball. So let's do this out here. So the mass of our bowling ball is 1 kilogram. Gravity is 10 meters. Acceleration due to gravity is 10 meters per second squared. And our height is 1 meter. So if we were to do this whole thing out, we see that we have 10 kilogram meter per second squared times a meter. And again, I want you to take note. Here, we have a kilogram meter per second, which is equal to a Newton. And then we have a meter, which is equal to a meter. So all told, we have a Newton meter, which, as you well know by now, is equal to a joule. So both potential energy, gravitational potential energy, and kinetic energy are measured in joules, and once again, they are the ability to do work. Apply a force over a distance. Okay, team, I think this is all you need for right now in order to do your homework. Thanks for watching, and I will see you on Monday.